Hi. Yeah, I'm Anna. I work on Node Core. That's basically all I really do. And I have the slides up for this talk. I mean, this is a live coding talk, as you may have read in the schedule. So slides only have so much value. But if you want to follow along, you can do that. Also posted the link on my Twitter. Yeah. So I'm going to be live coding a Node.js feature. I hope that goes pretty well. What I picked is set timeout because, it's a somewhat easy feature that still shows all the layers and features that Node.js has for its built-ins. And so I think a lot of people think set timeout is just part of JavaScript, but it actually just is not. Most JavaScript runtimes come with set timeout because that kind of API makes sense, an asynchronous one, but it's not actually specified in the language. So it's just something that browsers came up with, standardized on their own side, and Node.js was like, yeah, okay, if people are used to this API, so we're going to do that. Node.js uses libuv as the event loop library behind it. And because Node.js is single-threaded, essentially, we have worker threads, but those are still single-threaded Node.js instances. The event loop library has to be the one that actually figures out when to run a timer and how to run it. So if you're dealing with libuv, the first two things that you're going to have to know is there's two kinds of objects that you deal with. There's handles and there's requests. So handles are things like network sockets or file system watchers, things that generate multiple events over their lifetime, whatever that means. And there are requests, which are once only things, fs.stat, fs.open, connecting a network socket. You schedule them once and they have one result. And you might think, okay, timers, set timeout, that is a request because you, because it has one result, but it actually provides them as handles. It's going to be relevant. And that is because it has the same backend for stuff like set intervals, so you can have repeating timers. When we implement set timeout, we actually need to store some data asynchronously. So we have to have some object where we actually keep track of the timer function, libuv data, which we don't have to care about much, but we still have to store it somewhere. Because it's libuv data, we need to have a C++ object attached to it. Because we want to interact with the timer from JS, we have a JS object attached to it. To that C++ object, ideally. And we have async tracking, because that's a feature of Node.js Core that is, it is actually experimental at this stage, but that is because the API may change, and we're still pretty much committed to providing async tracking. And if I have the time, I'll show some of how that works for set timeout. Okay, so there's a few internal helper classes in Node.js that just help us provide some of these features. And we're not going to deal with most of these directly, but just going to mention it because they're going to show up. So we have this memory retainer class, which a ton of other classes inherit from. And it's mostly just things that we want to be able to show in the heap dump in the inspector, if you've ever used that. Including all JS objects and C++ objects that are directly attached to C++ objects. So we call that base object. Then we have async reps. Those are is a subclass of base object that additionally stores async metadata, which is basically two numbers, but still. Two numbers and a type field for whatever. So each of these native classes that inherit from it have a specific type, like TCP or timer or zlib or whatever. And then we have request rep and handle rep, which have one-to-one correspondence to the libuv object types that I mentioned. Because we have all these features and for implementing set timeout, we can use handle rep, which already exists. We have heap dump detection. We have the ability to directly connect JS and C++ objects without having to think about it a lot. We have the ability to keep track of async context, and we have some utility methods that apply to all libuv handles. I think closing is pretty obvious. That's the libuv equivalent of destroying a handle. Ref and unref are for indicating whether you want something to keep the event loop alive. That's not all that commonly used, but they're there. So if you run set timeout, the actual one that's built into Node, and you want to say, okay, this is going to keep the event loop running, but I don't want that. I want the process to exit early if if that is all that is left to do, then you can call unref on the result and on the return value of set timeout, and it's going to allow the event loop to close early. We also have this environment class, which is on some level just a grab bag of different different things that are associated with one Node.js instance, whatever exactly that means. Currently, effectively, we have one Node.js environment per thread. So for example, each worker thread would have one environment instance. It's always tied to one libuv event loop and one v8 isolate. And v8 also has this concept of contexts, which are essentially separate global objects. So it's kind of like iframes and browsers. You can have different global objects on the same heap, and we don't do a lot of that with Node, but we provide some tooling around that. Again, this is a quick example of how to interact with JavaScript values from C++ functions, because obviously you have to provide the ability to call C++ code from JS, and also the other way around. Yeah, so if I'm not going to explain all of that in detail. I guess the important parts are, so each C++ function gets an arguments array. Here it's called args. It's the common style in Node.js. You interact with these JavaScript values through classes that are called local, like local number or local value is the most generic one. And well, I mean, like, this is a pretty large API, and if you actually want to get into it, you're gonna have to do some reading on the V8 API, and there might be a few good tutorials out there. Yeah, okay. I'm not going to go more into that. I'm just going to show you while live coding. This is just more like for people being able to look up what I might be talking about. So Node.js as a software does have a few layers. So like when you're interacting with the exports from some Node.js built-in module like net or HTTP or something, you're never or almost never directly interacting with C++ functions. We have public modules which are all written in JS, including net and timers and everything. These are in the lib folder in our source tree. We have internal modules which are not accessible or requirable from outside of Node.js itself. These are for internal helpers. I don't think I'm going to be needing any of this in the live coding exercise. We have C++ modules which are in the source folder inside our source tree, and we have come up with ways to connect JS and C++ so that we can load these C++ modules from JS. Okay. Now for the actual fun thing. Y'all still awake? I saw some people sleeping, so yeah. Okay, so I have my local checkout of Node, which I forgot to switch branches from when I did my last exercise for this talk. There's a ton of files in there. Actually, can you see that well? Because I like my terminal transparent, but like, does anybody have issues with that? Like, would you like me to change that? Okay, cool. We're not going to be needing the terminal a lot. I figured now that it might be weird for people. Anyway, okay, let's start. So the source file for timers is, yeah, it's sourceless-timers.cc. Figured it would be something like that. So I'm going to be adding a few includes, which is kind of the C++ equivalent of require. Yeah, sure. Is that good? Okay, cool. So yeah, how did I figure out that I would have to require these files and what they're named? You can look it up. There's just like a ton of files in here, and with time you get to know the names. And also, so the handle rep is because I want to use the handle rep class for implementing our set timeout functionality, and the async rep inline classes. I figured it out while coding this talk that I need to include that. I'm also definitely going to add a few more using statements, which are ways to, like, C++ doesn't have actual namespacing, so you can import things from other namespaces. I think I forgot one, so I'm actually going to cheat and look at my previous preparation. Yeah, right, sorry. So handle scope. Handle scope is something that V8 uses for keeping track of your local values that you access from C++ when you're dealing with them, because it's not trivial to implement away from C++ to access JS objects, because C++ is pointer-based, so you like work with the location of an object, and V8 is a JavaScript engine, and it has a garbage collector that can move objects around. So yeah, that's tricky, and there's quite a lot of machinery that I'm not going to go into. Okay, so all of our classes for these kinds of things are usually called something rep for really no good reason, but it's yeah, it's just something that we do. So I would, like, if I didn't know about this, I would go to the libuv documentation, figure out how timers work there, and figure out that the class name that they use for timers is called uvtimer_t. So our class has one field of that type. We're also going to need a constructor that, well, we need that because we need to pass values to the handle rep constructor, which is this one, which is not enlarged, sorry. So it's going to take a lot of the same argument. So we're still going to need to associate a new instance of this class with a Node.js instance. We're going to need to associate it with a JS object. Sorry, that was unintentional. So we're going to pass some of these values. This is like, I know this is C++, and this is a JavaScript conference and everything. So this is basically defining the constructor and first calling super on it, which in this case is called handle rep, and super is kind of like the colon, or yeah, something like that. So the handle rep constructor, we can pass the environment along. We'll also pass the object along. That will take care of associating JS and C++ objects and everything. We're also going to pass the timer, and we have to pass it in, like, by doing some evil, or like, this is not really how you do C++. You're casting between objects of different types. And this is just how libuv does inheritance, because it's written in C, and C doesn't have inheritance. So you actually just cast objects of different types to each other, which is not ideal, but yeah, it's what C allows you to do. Okay, so I also mentioned that each async rep subclass has this own type, and I'm gonna add one to the list. So these are just numbers essentially. So we have to keep a list to know which one has which number. So I think this should work. And in the actual body that is not related to instantiating this object, we're going to call uvtimer in it, because that's the libuv way of setting up a timer. I'm gonna make sure. Yeah, I think this is okay. So UV timer in it, it's it just sets up some basic data and associates with the timer with the current event loop, which you get from the environment because that's the Node.js instance. And okay, so that's not all that much yet. The more important parts are we need to have ways to associate C++ functions with JS, provide binding functions. So one thing that we're definitely going to need is a way to start a timer, to actually specify a timeout and make it run. I think that's called UV timer start, yeah. Okay, sorry. So these are static functions, which means they're not like, I think JavaScript now has static functions too. We're gonna do some boilerplate, like this is what you're gonna do 1,000, or gonna see 1,000 times in our code base. So this is going to be a prototype method on the C++ class that we expose. So we're gonna get the current C++ class from the JavaScript class instance. And sorry, I'm gonna start the timer. I'll have to figure out which, okay. So we need to provide a libuv callback, which we're still gonna write. And we need the timeout. And we don't want it repeating, like the fourth argument would be specifying a repeat timeout. As for getting the actual timeout, what we're gonna do is we're first gonna make sure that the first argument is a number. And so this is how you get data out of values with V8. It's just something that you get used to if you look at their code base a lot. It's always this one same pattern: assign or return unwrap, which gets the current class instance from a JS instance, and also just reading JS values. It's done like this. I think this should be okay. Okay, so the libuv callback. So this is the function that's going to be called by libuv, from which we want to call our JS functions that was originally passed to set timeout. So we also need to find a way back to the timer class, which in this case is done like this, which is also a pattern that you see a lot in our code base. And it's fancy computation that actually figures out from a class field how to get to the original instance of the class that contains that field. And so because libuv is the event loop, like there's no JavaScript stack beneath it. It just runs. It just runs without any JavaScript stack beneath it, and that means that we actually have to set up some things for V8 to work properly. These are called handle scopes, so that V8 knows that we're actually going to do garbage collection, not garbage, like we're going to access JS objects in here. And because the garbage collector can move them, we need to create a handle scope to know, like, to let V8 know that we're doing that. Also going to create a context scope. So we're entering the context of the main Node.js global object. That is what this does. And then we're going to do the actual callback. And we have a function, utility function for that, which is called make callback, which is an absolutely terrible name. When I started working on add-ons for Node.js, that's when you first encounter that. And you might think it makes a callback, but it actually makes a call back into JavaScript. So like it doesn't create a callback. I think it's terrible naming, but I didn't come up with it, so yeah. And we can't really change it for backwards compatibilities, so what you're gonna do. So in the environment class file, we also have a list of strings, which might seem a bit weird that you're not actually directly using strings in the code that you're writing. This is an optimization that allows us to access strings that live for the entire time that a Node.js instance is alive. First, it allows us to do so fast, and secondly, it allows us to do so without the garbage collector needing to worry about them, because they're going to live for the entire time that Node.js is alive. And we're not going to pass any arguments, so that's 0 arguments, and null pointer is the arguments list. And I think we're like getting pretty close to being done with the C++ part, so that's nice. Okay, so we're also gonna need to follow a specific pattern for creating these kinds of objects. So we're first gonna just make sure that this is actually called as new. And so we need to get the current environment because we want to call the constructor of the timer wrap class. The two things we need is the environment instance and the current JavaScript object that we want to associate it with. So this is always this one pattern. And I think this should even work. Like just call the constructor directly. And if you're like used to writing C++, you're gonna like maybe get confused because like why is there no delete call to this? Why don't we do anything with the return value with the freshly instantiated class? That is because that is taken care of by the base object class, which associates JS and C++ objects. So like it will automatically destroy this object once it gets garbage collected, or in the case of libuv handles, in case we close them. So like that's a bit of magic, but that's okay. Yeah, I think so. Like the next thing that we need to do is we actually need to tell V8 that we want to expose these things in some way, and I'm gonna actually gonna go into our DNS library and gonna copy paste a bunch of code because it's just a lot of boilerplate. So there's this thing called function template, which is a V8 concept that doesn't really concern us because for us it's just the same as functions as far as this talk is concerned. We want to inherit the handle rep.js methods like ref, unref, close. We have one prototype method, which is called start. We have like this ton of specific tooling. Like you can set methods that are marked as having no side effect, which is cool because that way you can run them directly in the inspector and Chrome DevTools and know that nothing's happening. And so like I think DevTools uses that for auto-completion and a lot of other things. So I'm going to call this class Timeout2 because otherwise we're going to have name conflicts in the timers module because there's already a timeout class. And I'm not actually going to replace that. I'm just going to rebuild a new set timeout style feature. Okay. So T is the function template, but in this case, it stands for the timeout C++ class and the way we attach it. But yeah, a lot of Node.js native coding is just copying and modifying boilerplate. That's okay. Let's see if this compiles. I would really like that. It hasn't done so on the first try so far. But with this, we could actually, yeah, okay, it doesn't. Okay, this is just like underscore versus dash. I think that's forgivable. Okay, yeah, that looks a bit more like what I'm used to. Yeah, okay, that was my bad. So that's also a lot of what you do when you're writing C++, right? You're just gonna hit compile and figure out that it doesn't work. But luckily, I'm pretty used to working with Node, so this is not going to take long. Oh, right. Yeah, I nearly forgot about that. We need to copy some other boilerplate to actually make sure that the heap dump tooling that we have picks up everything that has all available information. In this case, we don't need to do much because all of the data that is associated with the C++ class is just right there, part of the class, and there's no extra memory attached or anything. And this works. So we're gonna do something that you should never do. You're gonna run node with -- expose internals. That is something that we do for testing. This is not actually sanctioned by us in any way. We're going to get the internal binding constructor. There's also a way to get that. Yeah, okay, it yells at us for, this is for testing only. Do not use it. So we're going to use that. We're going to look at the timers binding. Okay, there's a function that's called Timeout. This works, right? I can write stuff like this. No, I can't. So we're going to create a new timeout instance. We need to, so if you remember the name for the, that was on timeout for the callback. So hello world, and I'm going to start with 1 second. Woo! Okay, so we actually kind of have re-implemented set timeout. This is not a very user-friendly interface. So we're actually going to do what Node.js always does, and I think I accidentally started Skype. Yeah, sorry. That's the downside of having a lot of hotkeys. Okay, so we're going to go to the JS timers module. And we are going to use this timeout2 class that we have defined. We're going to import it. We're going to write a new function, which is cool set timeout. So we're going to take a callback. Okay, callback might be a better name. And we got to use the same function signature as for the actual proper set timeout. And we also want to export it, and I don't want to forget it, so I do it now. So what we do the same thing I just did in the REPL. We're going to create a new timeout instance. Don't think that actually took any arguments, no. We're gonna. So one thing that I also did not do in the REPL example is I did not close the timer, so that's a memory leak. So I'm going to have to do that here, and we also want to call the callback. We're going to want to do it afterwards, because if there's an exception, we don't want to not run close and again have a memory leak. I think this works, and so this is a very bare bones way to do this, but I think it should work. Sorry. Fun fact: this doesn't have memory type checking. So if for the milliseconds value we're going to pass in something that is not a number, it's going to crash. That's okay, because we're just doing live coding here. But actually, adding type checking to the actual set timeout function was the first commit I did for Node. So yeah, that's a meaningful thing to do. Okay, so we don't need expose internals. We can just run require timers. We have a cool set timeout function. I think the callback is the first thing. I always get the order wrong because it's not the standard Node.js style where the callback comes last. Console.log hi. 1 second, and that's it. And it works. So I don't think this is going to take long. So I'm actually going to want to show how to do the do the things that I mentioned, like actually see async tracking happen in Node. So that does not happen a lot. That people actually like write this lower level stuff. If you use async tracking in Node in some way, you probably do it through some library or whatever. So we're gonna call this test.js because that's all what I always call these. And so this is some boilerplate. It just looks at the debugging data that we get from the timeout from the async tracking stuff, and it prints them directly to standard error in not so pretty way, but not gonna care about that at all. So we're gonna do the same thing. Console.log hi. 1 second and no further arguments. Oh no, I don't want to do console.log because that actually prints the standard out directly, and that also goes through libuv, and so it's an async operation, at least in theory, and it's complicated. Okay, this is a bit nicer. So what we see is actually we have this timer class. This was the async wrap provider type that we defined earlier. It's going to get the ID 2. That's the first thing that our async hook sees. It was triggered by the trigger ID 1, so by the main script. We can actually access the C++ object this way, which is, you shouldn't do this because like our C++ objects aren't public APIs, but they can be used for logging or, well, hopefully we'll get rid of that, but you know, yeah. That might be an upcoming API change. We're going to see, okay, so there's this before and after events which indicate that the callback is actually running. So this is everything in between is JS code that was executed by our timer. And we're going to also see the timer close. So if I forgot that .close call, this destroy line would be missing and the object would not be destroyed. And if I may show one more thing. So I'm actually going to take a really long timeout. I'm going to do something that hopefully a lot of you are feeling pretty comfortable with, which is using the Chrome Inspector, the dev tools. Yeah, okay, yeah, I don't know. The important things we have attached to the current process, we're going to take a heap snapshot, and we can actually see instances of our timeout2 native class. We can see that they have a size of 64 bytes each, so that's not so terribly much, and we can actually access the JS objects associated with it. You know, heap dumps are a pretty valuable tool for looking what is actually at the heap, where do memory leaks come from. Like if I did forget to run .close on it, we would just keep timeouts laying around, and these native objects, they don't get that garbage collected, because they're tied to actual libuv instances, so they're not weak references. Yeah, so having heap dump support for that available is pretty cool. And yeah, that is everything that I wanted to show.